Hey everyone, welcome back to the channel. We will do the daily code question for day 16 today. And yeah, I have some bad news. I lost the streak. I was on a vacation and couldn't catch up on it. I'll try my best to, not let this happen the next time. And if I'm on a vacation, I'll at least try to solve the problem on my phone the next time. But yeah, uh, let let's like only let's let it be. Sorry. Um, The question here is about insert, delete, and get random. And we have to make sure that the time complexity is in big of one. Or what basically we have to do in this question is create or populate the logic inside a function called randomized set, which basically adds, deletes, and returns a random item from a particular set. And these three are different functions. So basically, we have to create an include function, a remove function, and a random function. And we have to make sure that the logic for everything is in big of one. Now, getting a random value in with a big of one, I'm not sure if that is like really possible. I tried to look into how Gaussian progression works, Gaussian normalization works, all of that, and I still couldn't figure out if there is a way to actually get a random variable in big of one time. If you know a way to do that, please let me know in the comments. But yeah, for this one, we will be using the function called random.choice, and we'll be importing random on the Python. But yeah, again, let me know if you find a better solution. So let's go to the whiteboard. I'll explain what exactly am I planning to do. I'm going to try a black background whiteboard that time. Let's see how this works, and let me know in the comments if you like this one better. So how I'm planning to work, or I'm planning to create the entire set is, I'm planning to distribute, or sorry, I'm planning to store the indices at which every element exists in a list in a separate hash map. For example, if what we'll do is we'll first create a list, okay, and if we are asked to insert one, we'll insert one. If we are asked to insert two, we will insert two. If we are asked to insert three, we'll insert three. If we are asked to remove, let's say two, what we'll do is while inserting, when let's say I'm inserting one, I'll create a hash map as well, and I'll store the index that this value one exists at in this particular list. So this is the list, and this is the hash map. Oops. As well. This is the hash map. Now, this value exists at index 0, right? So I'll store 0 here. Similarly, for value 2, I'll store at index at 1, so 1, so on. Okay. Now, what I'll do is, if I have to remove an element from this list, what I can do is, let's say, for example, if I want to pop 2, I'll go to this hash map, seeing where where do we have 2 in this list. It's at index 1. I'll go to index 1. I'll delete this. Okay. Now we have empty space. Now we can't leave empty space because empty space will either be filled by any integer or some other value. And as in the question, it's mentioned that the values that can be added to the set range between negative 2 to the power 31 to 2 to the power 31. So you can understand, right? It's a huge how to say this, huge range. So instead of leaving it empty, what we can do is we can take the last element, whatever element exists at the end, we'll replace that. So we'll replace the empty part with that, and then we'll pop the last element. And when we replace this, right? So initially, let me get white color. So initially 3 was at index number 2, right? After deleting, 2 doesn't exist anymore. at index 1, but I'm replacing the value 2 with 3, and I'm going to update it in the hash map as well, that 3 now exists at index 1. Now, in the hash map, 3 also uh, exists at hash map 2, right? So, okay, no, my bad. I won't update the value here. Okay, the value will be deleted. This entire value will be completely deleted. The existing value 3 here, the index here will get updated to the new index value, which is 1. So my new hash map would be 1 is at 0, 3 is at 1, and the new list will be 1, 3. There we go. So this is what we will do in the solution. Let's go code. So I'll just quickly copy paste what I have already written in on my code, because it will take too long to type. So let's first initialize the hash map value to index. So I'll store the value as the key and the index at which it exists in this hash list as value, key comma value for, and this is the hash list. It will have all the items in the set. How will we insert it? Inserting it is fairly easy. So first we check if the particular item, the value that we're receiving, already exists in the hash list or not. If it does, according to the question, we have to return false. It returns true if the item was not present, false otherwise. So return false. But if it does not exist, then append it to the end of the hash list, append the value to the end of the hash list, and self.hash value at basically the hash map, add this value will contain the index at which this value is stored inside hash list. I hope you understand. So this part basically is 0 here, because we are storing it on the first index, right? This is the index of the hash list at which the value is stored, and hash map is a map of value to index. So I'm storing the first item, let's say 5. If 5 was provided as value here, then hash map will contain 5 is stored at 0, and the hash list will contain just an element 5. Okay, now how do we remove? So remove is quite tricky. So let me get this. Yeah, there we go. So how do we remove? If the value exists inside the hash list, then we have to remove it. Otherwise, we'll return false. And that's what is mentioned in remove as a remove one item value. If it is present, it will true if you are able to remove it. Otherwise, we have to return false. There we go. So how do we get this? If the value already exists in the hash list, which means that, yeah, we can remove it, first get the index in from the hash map. So if it exists in the hash list, it exists in the hash map that I've created. Now I got the index at which the value is stored in the hash list. Now what I'll do is, this actually can be done using just this index keyword as well, but since I'm using it, so creating a how to say, a new map dictionary, then I'll use it. Then end value, I'll just get the last value. Just like I mentioned, I'll move the last value to the current value. And in Python, I can just use -1 to get the last value of the list. So now what am I doing? In the current list, which is like the set of all the variables, at index I is the index at which I have stored this hash map value. Take this particular value and replace it with the last value. Then pop the last value out, because we have 2 copies now. And then update the hash map, which is for the value, this value, the new index that I've stored it at is the index of the old value. Then return true. And that's it. That will be a big O of 1. Big O of 1 time complexity solution. And for this part, we can just return choice, convert it's already a list, right? So I just need to use self out hash list. There you go. Let me quickly import it as well. Let me submit. And there you go. It's accepted. It's not efficient. I understand. There are much more efficient solutions on that, but it's a good one. And I'll see you in the next one. Bye bye.